Hi Flashes! So today we are going to be talking about similar figures. So the thing to remember about similar figures is corresponding sides of similar figures are always proportional. And angles of similar figures are always congruent. And remember, congruent means the same. Okay? So looking at this figure, they tell us that these two figures are similar. So similar, they're going to have the same shape, but they're going to be different sizes. So that's what similar means. Same shape, different size. Okay? So they want us to find the value of n. So if you notice, n is down here at the bottom, and there's only one way that we can really solve for n here. Well, actually, there's two ways. And one way is by setting up a proportion. And there's a lot of different ways that you can set up these proportions. Just remember that when you set up these proportions, that everything in the proportion needs to be lined up with what you're talking about. So I tell my students, if we're trying to solve for n, which is one of these sides, keep n in the first fraction in the numerator, and then just pick one of the other sides in that same triangle. So remember, a proportion is a fraction over a fraction here. So if we're trying to solve for n, make that your first variable in the proportion, and then just pick one of the other numbers. So let's say I pick 12. Okay? Now, what you pick over here does matter. Okay? So if you pick n first in your proportion, in your fraction, you need to find the corresponding side to n over here. So this one's a little bit easier because they're both facing the same way, but the corresponding side to n over here is this 3. So if I put n on top, I need to put 3 on top over here. And then if I pick 12 as my other number, so 12 was the side going straight up and down, I need that corresponding side over here, so that number is 4. So I need to make sure that 4 goes down here on the bottom, okay? And the reason why is whenever you set up your proportion, again, everything has to be aligned. So this fraction was talking about the big triangle, this fraction was talking about the little triangle, and then these were corresponding sides that we lined up with, okay? You could have picked 15 instead of 12, but if you picked 15 instead of 12, your fraction, your proportion, would be n over 15 and then 3 over 5, because 5 is the corresponding side to 15. Either way, though, you're still going to get the same answer. Oh, sorry, that should be 5. Either way, you're still going to get the same answer, okay? So remember, to solve a proportion, you just cross multiply. So 4 times n is 4n, 12 times 3 is 36, and then when you divide both sides by 4, n is going to equal 9. Okay? And the other way to do this is if you look at the small figure and then look at the corresponding sides on the bigger figure, you notice that this side went from 4 to 12, this side went from 5 to 15, so you know based on those numbers that this triangle is 3 times bigger than this small triangle, because 4 times 3 is 12, and 5 times 3 is 15. So if I wanted to figure out n, all that I would have to do is take 3 times 3 as well, and that would give me my 9. Okay? However, all of your guys' examples aren't as easy as that one, so you're going to have to know how to set up the proportion. Okay? So, if you're trying to find a corresponding side, you need to set up a proportion. So that's why up here we said corresponding sides are proportional. When it comes to angles, those are the same. So down here it says find the value of x in the similar figures. Well, x is right here in this corner, so that's talking about an angle measure. So since we know that angle measures are the same, we need the same angle measure over here in this triangle, which is going to be that 35. So x is going to be equal to 35 degrees. Okay, so again, If you're trying to find a corresponding side, set up a proportion. If you're trying to find an angle, just find the matching angle in the other figure, and then those angles are congruent, so they are the same. Okay, so let's do some more examples. So here, they want us to find x, and x is a side, so I just need to set up my proportion. Again, if you're setting up your proportion, I want your variable to be the first number in your proportion, and then just pick one other number that's on the same side of that triangle. So you could pick the 6, or you could pick the 11. I don't really care, just pick one. So let's say I pick 6, okay? And I like to use different colors to help us out here. So I picked x, and then I picked the 6, okay? Now your second fraction in the proportion does matter, because if you picked, oh sorry, that's blurry. Okay, sorry about that. So if you picked x first, so x was this side from M to O, you need to find the side that's corresponding to x over here in this triangle. So if you notice, x looks like the biggest side, or close to the biggest side, so the corresponding side over here to x in the big triangle is going to be that 20. So if x is in my numerator, I need to make sure that 20 is also in the numerator here. Okay? Then if you pick 6 down here in the denominator, 6 was talking about this side in the small triangle, so I need to figure out what side is corresponding to 6 in the big triangle over here, which in that case is going to be the 12. So 12 is going to go down here in the denominator, and then I can just cross multiply and divide. So let me get out my calculator. So 12 times x is 12x. 20 times 6 is 120, and then to get x by itself, you just divide by 12 on both sides, and 120 divided by 12 is 10. Alright, so let's try another one. So here, again, we're trying to find a missing side. So whatever side you're looking for, your variable I want you to put in your numerator in the first proportion, and then pick one other number on that same figure. So the only other number that they give us is 9, so we have to choose 9. Okay? Then in your second fraction, you're looking for its corresponding sides. So if y was your numerator, you need to find the corresponding side to y over here in the smaller figure, which in that case is the 15. And then 9 was talking about the side of the rectangle, so you need the side of the rectangle in the smaller figure, which is 5. Okay? So, again, cross multiply and divide. So 5 times y is 5y. 9 times 15 is 135. And then last step is to divide by 5 on both sides, and you should get y is equal to 27. Okay. Now moving down here to the angles. So angles, just make sure again that you find the corresponding angle on the other figure, and then the angles are going to be the same. They're going to be congruent, okay? So here, if we're trying to find k, we need to find the corresponding side of k over here. And there's a couple different ways that you can do it, because as you notice, it kind of looks like it's just churned a little bit. But this angle down here kind of looks like a right angle, which I know it's not, but I know it's going to be approximately 90 degrees. And if you look over here in this triangle, the only one that kind of looks like a right angle again is this one down here. So if you're having a hard time figuring out what angle represents K, well, just look at another angle and see, okay, so they're both on the right side here. So if I just were to tilt this, K is going to be corresponding with the 29 degrees up here at the top. So I know for sure that K is going to be equal to that 29 degrees. If you guys saw that from the get-go, then you can just say, oh, K is 29 degrees. But again, sometimes you have to be careful because the figure will be turned or rotated, so you just want to make sure that you know what corresponding sides match up and what corresponding angles match up as well. Okay. Same thing over here. So here we're trying to find S. And if you notice, S is this obtuse angle here. So we know for sure that it's going to be greater than 90 degrees. And if you look over here, the corresponding angle or angle measure to that is that 122. So we know that S is going to equal 122 degrees. So angles are a lot easier since they are congruent, but sides are pretty easy too, as long as you make sure that your numbers are correctly lined up in your proportion, then you can just solve the proportion like normal, okay? All right. So that was a basic introduction to similar figures. Now you guys are going to look at different triangles and then once again trying to find missing side lengths. So here they're saying that Tyrone was standing next to a light pole in the middle of the day. His shadow was 1.5 feet long and the light pole shadow was 5.5 feet long. If Tyrone is 6 feet tall, how tall is the light pole? So over here they represented it with a picture. So Tyrone was 6 feet tall. His shadow was 1.5 feet. And if you just were to connect those lines, you just created a little triangle. Okay? Then over here was the light pole. We're trying to figure out how tall it is, so that's why H is right here, because that's what we're trying to find. And then its shadow was 4.5 feet. So if you're trying to find the missing side length, once again, just like we done on the back side, all that you have to do is set up a proportion and solve. So they set it up as the shadows first, so they put Tyrone's shadow 1.5 over the light pole shadow 4.5, and then they had it equal to his height of 6 over the light pole's height of 6. Again, I would have had you guys write it like this. So H was your variable. So H was your variable, so I would want it to go up here in the top over the number that's on the same triangle, which is 4.5. And then set it equal to the corresponding side. So since H was talking about the height of the light pole, I would want the height of Tyrone up there, so that would be the 6, over his shadow, which was 1.5. Either way, though, you're still going to get the same answer as 18. Okay? So let's try one. So a statue casts a shadow 30 feet long. At the same time, a person who is 5 feet tall casts a shadow that is 6 feet long. How tall is the statue? So they represented it over here in our picture. So all that we have to do is find the height of the statue. So again, whatever your variable is, I want you to put that first in your proportion over the other number that's in that same triangle, which is 30. Then in your second fraction, I want you to put the corresponding sides. So since H was talking about the height of the statue, I need the height of the person, which is 5, over his shadow, which was 6. So once you have your proportion, you can solve it. So 6 times H is 6H. 30 times 5 is 150. Divide both sides by 6, and 150 divided by 6 gives us 25 feet. Okay, so I want you guys to try the next one, so just try number 2. So go ahead and pause the video and try it on your own, and then play it when you're ready. Okay, so you guys should be done with number 2, so let's see how you guys did. So we are trying to find the height of this building here. So if you're trying to find the height of the building, again, put the variable in the top in the numerator over its shadow, so that was 72 meters long. And then just make sure you have the corresponding sides over here. So the parking meter was 1.2 meters tall, and its shadow Alright, so that should have been your proportion. So once you cross multiplied, h times 0.8 is 0.8h. 72 times 1.2 gives us 86.4. And then last up was to divide by that 0.8 on both sides. And we get h is equal to 108 meters. Okay, so good job if you got that. So the last one here, one does show up on the homework assignment, I believe. So we're still doing the same exact thing. However, it's kind of like the triangle is flipped and then flipped again. So we just need to make sure that if we're still trying to find the missing side, that we just make sure all of our numbers are lined up in our proportion. So if you're trying to find the distance d here, again, put d in the numerator in your proportion, and then put the other number that's in that same triangle as d. So d is talking about the side length of the big triangle, and the other number that's talking about the same triangle is 1.8. So 1.8 should be down here at the bottom. Okay? Now, this may be a little difficult to figure out the corresponding sides over here. However, if you notice, D was talking about the distance from the point to the right angle. So looking over here at the small triangle, what side starts at the point and then goes to the right angle? Because if you guys notice, it's the 1 here. That's the corresponding side to D. If they both started at a point and then went to the right angle, that means that they are corresponding sides. And then that means that the 1.8's corresponding side is the 0.9 over here, because it started at the right angle and then that was the height of the triangle. So yes, it does look weird, but once you figure out what are your corresponding sides, it's just as easy as what we've been doing. Okay, so just solve it. So 0.9 times d is 0.9d. 1.8 times 1 is 1.8. And then last step is to divide by that 0.9 on both sides. And 1.8 divided by 0.9 gives us 2 kilometers. Alright, so that is it on similar figures today. So if you guys have any questions, please let your teacher know. Thank you.